Hello guys, welcome back to another video. So in today's video we're gonna see how to make subsets of all the elements given in a list. So what are subsets? Now suppose you have a list A equal to say ABC. ABC are elements and you have to make print all the subsets. So subsets are given like first you take all the possible list with one element, that is A, then B, then C. Then you take all the possible two element list, like you form all the possible two element list, which will be A, B, B, C, and C, A. Then you form all the possible three element list, which is only A, B, C. Now here we are not going to focus on the arrangement of these, like A, B, C, C, B, A, and A, C, B are all same. So these are called subsets. Now we have to write a program which can make all the subsets of the elements which are given in form of a list. So what is the basic idea behind this? The basic idea behind this is that this is what is concatenation. But if you do, this is also concatenation. So using this technique and using the concept of binary numbers, we are going to solve this problem. So what are binary numbers? Now suppose there is any number you take, for example, for simplicity, let's take 3. So you can express this number in form of zeros and ones. So suppose there are different blocks. One block is of 2 to power 0, which is 1, 2 to power 1, which is 2, 2 to power 2, which is 4, 2 to power 3, which is 8, and so on. Now you can either use this block or not use this block. There's only two options. That's not that you can multiply one block by 3, you can divide one block by 4. No. You can either use the block or you cannot use the block. And it's really weird that you can actually form any number by using this. So using the same concept of binary numbers, like suppose you have 3, you have to convert 3 to binary number. So first you have to use 2 to power 0, which is 1, and then 2 to power 1, which is 2. So 1 plus 2 is 3. But the basic rule behind this is the thumb rule, that you have to start from the left. You can't directly use 2 to power 3 or 2 to power 5 like that for big numbers. You have to start from the left, right? And you have to keep on adding till you get the required number. Now this can be this can be different combinations. Suppose that instead of, like, suppose you have to express 8. So I won't be writing 2 to power 2 plus 2 to power 1, or like any of those combinations. I can directly write 2 to power 3, which is 8. Right? So I can use directly the fourth block. Now similarly, this is how basically how binary numbers work. Right? Now there's an inbuilt function in Python which changes numbers to binary numbers. So which is known as bin, binary. So suppose if you write binary of 3, it gives 0b 1 1. So the 0b part can be ignored for now. So suppose you convert this to string, okay? Because if you don't convert it to string, you can't do slicing, okay? And then you slice a number, okay? This is what we want. Now this works for anything. Suppose you write for 8, right? This is what we wanted. Now suppose it's 3, right? So first you're going to write all the binary numbers, okay, from 1 to 2 to the length of A. Now why is it so? Now suppose there are three, like again, let's, for simplicity, let's just 3 elements. There are 3 elements. So you have two choices for each element. Either you take it, which is 0, or you don't take it, which is 1. So, if you know a bit of combinations and permutations, you know that the number of possible cases would be 2 into 2 into 2 into 2 into, because all are compulsory events. So, the total number of cases, or the maximum number of cases which can be formed, is 2 to the power n, right? But now, since we are not including that empty subset in which nothing is included, which is all is 0 0 0 0. So, for that, we are subtracting -1. So, we are going to write the first code, which is going to give us all the binary numbers from 1 to the number which is required, right? To 2 to the power n. N is a length of it. Now once we write that, we are just going to concatenate that with the element. Now suppose you have the number, say 1 0 1 0, right? 0 1 0, and you have elements a b c. So 0 will get multiplied by A, 1 will get multiplied by B, and 0 will get multiplied by C. And you just concatenate them. Concatenate them. A into 0 plus B into 1 plus C into 0. This is what we want. Now, I can get any subset just by changing these numbers. Right? Suppose I want all three, or I don't want it. Right? Now, this is what are subsets. Either it is there or it's not there. So this 0 1 0 or 1 1 0, 1 1 1, 0 1 1, all these are the binary numbers which have made before. So that is what. Now coming to the program, first you define a function subsets A, which takes the input as A. Like here, you give input as A, and then it gives you the result as S, which is the set of subsets. So this first loop here, we have basically used just three loops. The first loop is to generate all the numbers which are which I mean the binary numbers. Now the question comes that why do we need this second loop? Why do we need the second loop, right? So for that, let's just hash this for some time. Okay, just to understand it, why do we need the second loop? So this is the set of binary numbers which we are getting. Now the question is that is it wrong? No, it's not wrong. It's correct. But now, how would you use this to just print A? Now see, here it's understood that you are going to print 1 into A plus, I mean A into 1 plus 0, B into 0 plus C into 0. Right. What about this? Now this would give an error because, or it would just complicate the program, because now every time here you need to change the length. Uh, I mean the length of the subset is changing, which is further going to create the problem and which is contradicting with the logic we started with. So for that, we're going to start a new loop which is just going to add zeros before this, because if you add zeros after, it will make a difference. If you're adding zeros to the right side of 1, which means that you're moving one block to the right side, right? So if you add 1 0 to 1, you're moving one block to the right side. But if you add to the left side, it makes no difference. So what's wrong in adding? So we made, and now we got this. This is what we wanted. Now see, it's quite clear now that A into 0, B into 0, C into 1. A into 0, B into 1, C into 0. This is what we wanted. Now the final loop is that we have to print, we have to just finish this program. I mean this uh, definition of program on this subsets. Now how do we do that? For that we have the third loop, which is also quite simple. So here what we do is, now we are, so suppose we are taking this at a time, this first out of this whole list. Now this is our W list. This is the one which is highlighted. We are first taking this first element. That first element we are taking the first element. So first element W of 0, right? There's a big box, this big list in that first element. In that first element, right? It's quite weird to listen, but yeah. Then we're taking second element, then third element. It goes on till nth element. Then again we move to the next block. So then there's a big box. Then there are more small boxes. In that there are smaller boxes. The most small box is the number which we need. We're accessing it through this program. So after it's done, we'll add the subset in our main subset list and then again make m0, because if m is not, if we don't change this m, suppose you don't change m, and you write this is what s we want, right? So you write this, you're going to get something like this, because m is not changing. CB is there, CB is there, so it's just adding BC there. BC is a subset, CB is a subset, but it didn't change it. It is just appending it to itself. So for that not to happen, we have to make m equal to 0 after the first loop gets over. There are two loops, right? So in the nested loop, in the first loop, after the first loop gets over, after the first subset, again m has to be 0. M is like a paper. You have to erase it every time after you make a subset. So now it gives